Welcome to my channel Simple Concepts by DJ. Today I'm going to teach about capacitance. We are going to see about the theory of capacitance. So what is capacitance is all about. So you have seen this capacitor, right? The capacitor is an electrical device. Okay, it is you can see it in your ceiling fan and many radio circuits and all. You can see these capacitors. So the capacitor means the unit of the capacitor means the ability of the device to store electric charge is called as capacitance. Device means here the device is capacitor. So the ability of the capacitor to store the electric charge is called as capacitance. Okay. So see the capacitance, the unit of capacitance is farads, equal to farads. Okay. So what is this farads equal to? So this farads is equal to farad. There is a famous equation, that is Q is equal to C into V. Q is equal to C into V, where Q is called as the charge, C is the capacitance, and V is the voltage. Okay, the voltage that has been developed across the capacitor is called as the voltage. Okay, so Q is equal to C into V. Q is equal to C into V. So what is C is all about? C is equal to the ratio between the charge and the voltage, that is Q divided by V. This is the formula, basic formula for capacitance to find the value of capacitance if the charge Q and the voltage V is given. So C is equal to Q divided by V, right? So here, so the unit of C is farads. So what is 1 farads equal to? 1 farad is equal to 1 farad is equal to the ratio between the charge and the voltage. See, the unit of charge is coulombs, 1 coulomb. Okay, 1 coulomb divided by the unit of voltage is volts, that is 1 volt. So therefore 1 farad is equal to 1 coulomb by 1 volt. So this is the 1 coulomb by 1 volt is the exact equivalent for 1 farad. Okay, so now we are going to see about the capacitance of an isolated sphere. Okay, so let's get started with this one. See, capacitance of an isolated sphere. See the capacitance of an isolated sphere. So capacitance of an isolated sphere. So first thing is you just imagine a sphere. This is a sphere. This is a sphere. In this sphere, the center point is being situated over here, and let us assume that the radius of the sphere is r. Okay, the radius of the sphere is r, and you should imagine that a positive charge, a group of positive charge is being accumulated at the periphery of the sphere. A group of positive charge is being accumulated at the periphery of the sphere, and the other condition is this sphere is in a medium. Okay, this is in a dielectric medium. Okay, let us assume that the medium has a relative permeability. Let the relative permeability of this medium be epsilon into r. Okay, so this is the relative permeability of the medium in which this sphere is situated. Okay, so now what we need to do is, we know that Q is equal, for this first thing is what we need to do is we need to find a parameter. Okay, that is called as free surface potential. It is called as free surface potential. What is potential is all about? Potential is nothing but the voltage that is existing across the capacitor, or a voltage that is existing across the sphere. Okay, a voltage is being developed. So this is free surface potential. So free surface potential is nothing but it is indicated by capital V. Okay, so we know that the formula for capacitance is Q is equal to C into V. So C is equal to Q divided by V, or V can be equal to the ratio between the charge divided by capacitance. Okay, so now we are looking into the free surface potential, that is V. So what we need is V is nothing but the ratio between the charge that has been developed at the periphery of the sphere to the capacitance, right? So here V is nothing but the charge. What is the charge that has been developed? That is nothing but plus Q. Plus Q is the charge that has been that has been developed at the periphery of the sphere, at the outer surface of the sphere. So what we need to do is this is equal to plus Q divided by what is the capacitance value? Capacitance value is 4 pi. 4 pi into epsilon naught into epsilon r into the radius. What is the radius? Radius is r. So this is the value of free surface potential for V. So V equal to Q divided by C. But we are interested to find the capacitance of this isolated sphere. Okay, the isolated sphere. So in order to find the capacitance, capacitance is expressed as C, capital C. Capacitance is C equal to Q divided by uh, C equal to Q divided by V. Okay, so we need to put a Q in the numerator divided by V. V is the free surface potential value which we had obtained. So that is nothing but Q divided by 4 pi into epsilon naught into epsilon r into r. So which is nothing but Q divided by 1 into 4 pi into epsilon naught into epsilon r into r divided by a camera number divided by Q. Hey, camera number. So this is equal to so Q gets cancelled. So you are left out with the capacitance is C equal to 4 pi into epsilon naught into epsilon r into r. So this is for any medium. Okay, this is for any medium other than air. So this is for any medium, for any medium in which the sphere is located. For any medium, this is the capacitance value. But in the case of air, if it is for air, for air, this epsilon r will be equal to 1. So when epsilon r is equal to 1, automatically what will happen? The capacitance value will change. So C will be equal to 4 pi into epsilon naught into r. So this is the value of capacitance when the relative permeability is 1. Okay, this happens only for air. If air is used as the medium, this is the value of capacitance, right? So similarly, the unit of capacitance, we need to add the unit of capacitance. Unit of capacitance is farads. Here is also you need to add farads, right? So now we are going to see about the spherical capacitor. We are going to see about the spherical capacitor in which the outer sphere is being earthed. So this is the condition. So what is a spherical capacitor is all about? See, you need to consider a spherical capacitor. A spherical capacitor means it consists of an outer sphere and it also contains an inner sphere. It contains an outer sphere and it contains an inner sphere. Both the spheres will have a center point, common center point, and they have different radius. So this is looking like a concentric circles. This is looking like a concentric circles means you have one single center point but of different radius. The other circle will be having different radius. They'll be having different radius, but every circle will be having the same point, that is the center point. So that is called as concentric circles. Here if you look into at the top view of the sphere, this is how it looks. It looks like a concentric circle. It is constructed in such a way that the inner sphere is impregnated, or it is being inserted, okay, it is inserted inside a outer sphere, an external sphere. Okay, so let us assume that this is the external sphere and this sphere is being earthed, it is being connected to the ground, and this is the inner sphere. Let us assume that this inner sphere has a radius a. Let the radius of this inner sphere be a and the radius of this outer sphere be b. Okay, so this is the major difference. You have two different type of radius. The smaller sphere is having a radius of A and bigger sphere is having a radius of B. Okay, and this outer sphere is being earthed. So now let us assume that the inner sphere we are supplying a voltage such that the inner sphere acquires a charge of plus Q. Okay, it acquires a charge of plus Q, and this plus Q is being situated at the outer periphery of the inner sphere. So when this inner sphere gets plus Q charge, the outer sphere will be getting automatically, it will be getting minus Q charge. So minus Q charge will be distributed evenly at the periphery of the outer sphere. So you'll be getting minus Q charge. So this is the concept is all about. So now what we are going to do is, first thing is, I'm going to consider this I'm going to consider this inner sphere. So now what is the, now I want to find the free surface potential of the inner sphere. So free surface potential, potential, this is for inner sphere. So I'm indicating it as vi, since I is for inner. So vi is the free surface potential of the inner sphere. Okay, so vi will be q divided by, so we know that q equal to cv, right? So v will be q divided by c. So q is positive, plus q. So plus q divided by c is 4 pi into epsilon naught into epsilon r into the radius. So the value of radius is a. So I am putting it as dot a. So let us assume that this is equation number 1. Now again I am finding of the free surface potential, free surface potential, free surface potential for the external sphere. So I am indicating it with V naught, external sphere or the outer sphere. So V0. V0 will be, say I have the outermost shell, the external part, the external periphery of the outer sphere has acquired a negative charge, that is minus Q. So it will become minus Q divided by 4 pi into epsilon naught into epsilon r into B is the radius of the outer sphere into B. So this is being considered as equation number 1. So now what I'm going to do is I'm going to add the total sphere, total potential. So what will be the total potential? Total potential is nothing but V total. Okay, V total is equal to Vi plus V0, V naught. So that will be equal to Q divided by 4 pi into epsilon naught into epsilon r into A plus minus Q divided by 4 pi into epsilon naught into epsilon r into B. Now I am going to take this terms common. Q divided by 4 pi into epsilon naught into epsilon r into 1 by A minus 1 by B. So which is nothing but Q divided by 4 pi into epsilon naught into epsilon r. This will be AB, B minus A. So this is the value of V total, the total potential that has been developed across this spherical capacitor. So now if I want to find the capacitance value, C, what is the capacitance value? C is equal to Q divided by V total. V total. So that will be equal to Q divided by, what is V total? V total we have found it as Q divided by 4 pi into epsilon naught into epsilon r into B minus A divided by AB. B minus A divided by AB. So it will be Q by 1 into 4 pi into epsilon naught into epsilon r into AB divided by Q into B minus A. So Q gets cancelled. So this capacitance value will be C equal to 4 pi 4 pi epsilon naught into epsilon R into AB divided by B minus A. So this will be the capacitance value, C equal to 4 pi epsilon naught into epsilon R into AB divided by B minus A. So the unit of this capacitance will be, this will be expressed in farads. Okay, so this is the derivation for the spherical capacitor in which the outer sphere is connected to ground or is earthed. So this is the condition. Okay, based on this condition I have derived this equation. Thank you all for watching this video. I hope this video will be very helpful and it will be very useful. Please go through the derivation. Thank you.